Okay, so now I want to move on to measuring and measuring the angles and studying the diagonals. Okay, so let's measure these angles. If you have a trapezoid, or rather a protractor, I want you to be measuring the angles. All right, so this angle, if I extended this line up, it would get up to 40, let's say 45. Maybe it's closer to 43, but let's say 45. So this is 45 degrees. And angle A, B, C, and D. Now, there are many of you who are, if you don't have a protractor, I've asked you to assign the measures to these angles. You need to do that considering what the way that angles work and math works. So that's why I keep saying use your math knowledge. So if you look at this and you say this is anything bigger than 90 degrees, anything bigger than a right angle, then no way, that's not acceptable. If you say it's 30, all right. If you say it's 50, that's okay. 60, 70, 80, not as good, but you can tell that this is not greater than 90 degrees. So it has, and you could probably even tell that it's around 45. Okay. So don't turn in those exit tickets saying that this is 95 degrees. No way. 95 degrees is an obtuse angle. It is greater than 90 degrees. Okay, so angle D is 45 degrees, and we know that this is a trapezoid, because a parallelogram is a kind of trapezoid, and a rhombus is a kind of trapezoid, kind of parallelogram. So this had better be 135 degrees, because if it's not 135 degrees, I have done something wrong, right? Okay, so when I measure this angle, it's actually approaching 140. Okay, the exact, and that's an error. It's not a perfect rhombus. Okay, but I know that if this is 45 degrees, this has to be 135 degrees, because these two angles have to equal 180 degrees. So if I measure this slightly more precisely and this slightly more precisely, I would get 135. So I'm going to say it's 135. Remember, this was like 43, so little error in my measurement there. But we'll say that that's 135. That's pretty close. And it's about 5 degrees off. Angle A. Angle B. I can tell pretty much. Ooh, that one's definitely off. Huh. It must be my sides didn't measure quite right. But it would have to be 45. It looks like it's closer to 40. So I'm going to call it 45. I'm going to assign it the measure of 45 because I know that it should be the same as this one. But you can tell that I've done, my rhombus isn't perfect here, because if it was perfect, then that angle would be about like that. Okay. All right. So, and that, that doesn't bother me very much. There's lots of little places to make mistakes when you build these, even when you are the math teacher. So that doesn't really, I wouldn't expect anything more than that from you either. Lots of little places to make mistakes. Okay. So this one is approaching 43 or so. I'm sorry, it is approaching 135 or so. Yeah, maybe it's 136, 137. So it's, you can see where my small errors are. But okay, so we're going to call it 135. All right. So in this rhombus, angle A and angle D equals 180 degrees. It's going to always equal 180 degrees. Same thing on the other side, B and C. Angle B plus angle C equals 180 degrees. Angles D and B are the same. Angle D is equivalent to angle B, which will always be the case. Angle C is equivalent to angle A, which will also always be the case. The length of each side is equivalent. Okay, now we need to take a look at the diagonals as well. The diagonals of since the length of each side is equivalent, the diagonals are going to be special too. They're going to be a little bit different than the diagonals on a parallelogram. Okay, if you remember the diagonals on a parallelogram, they bisected one another at this midpoint. That's why we called that M yesterday. The midpoint M. They bisected one another. And do these angles also bisect one another? I'm sorry, do these line segments also bisect one another? Well, let's measure them. This is, let's see, what is that? 1 and 3/4, 6, 7/8, 1 and 7/8 inches. And no, that's not right. 1 and 7, this can't be 1. Oh, no, it is. Yeah, 1 and 7/8. 1 and 7/8 inches. And this is pretty close to 1 and 7/8 inches as well. So just like in a parallelogram, and you can see that this is going to bisect as well. Right, so that's what, about 3/4 of an inch, 3/4 of an inch. Okay, so the diagonals bisect one another. And there's an additional piece. The measure of each of these angles, angle BMC, is 90 degrees. So you can see that that's 90 degrees. And if this is 90 degrees, and all of these are going to equal 360 degrees, then this is also 90, that's 90, and that's 90. So they are all 90 degrees. So the diagonals bisect one another. The angles of bisecting line segments are 90 degrees. And actually, there's a vocabulary word I almost forgot. These would be called, these are perpendicular, right? They're perpendicular. They are perpendicular bisectors. Okay, so what do we have? We have a bunch of really important and good notes about a rhombus. And in particular, we have some important notes about how a rhombus is different than a parallelogram. Particularly, the length of each side is equivalent. The diagonals bisect one another. That was the same for a parallelogram. And the angles of the bisecting lines are perpendicular. Okay, so those two, the starred ones, are special for a rhombus. Okay, I think that that's it for this. Okay, one other thought. You're about to make a couple of rhombuses on your own, you need to be using those same strategies that I just showed you in the first video. And then when you get to the exit ticket, I saw a lot of exit tickets yesterday, and you'll hear me say this a few times during the course of the day. I saw a lot of exit tickets yesterday that they just weren't your best work. They weren't students' best work. I mean, the answer to this exit ticket should look an awful lot like this, right? It's going to look a lot like that. This example that I'm giving you meets the expectations of the exit ticket. There are people who are putting. Well, I guess I'll get to that later. I'll get to that later. This is what we're shooting for. Is this hard to make in Google Draw using the screenshots and Google Draw tools? Yeah, it is a challenge. And I would be, just as a side note, I would be perfectly happy if you figured out a way to take a picture of something like this and use that as your answer. If you need to do it, if you want to do it on paper, that's fine. But if you can't submit it any other way, then Google Draw is an okay way to make it. Okay. All right. Have a good rest of your day. Get the rest of this work done.